Hello everybody, you're very welcome to this episode of Programming and Algorithms. In this episode we're going to look at how Python implements linked lists. Now we'll recall from our talk in pseudocode that a linked list is a list of items like an array, but instead of having the values one after the other, each element of a linked list is made up of a node that has two parts, the value plus a pointer to the next element in the linked list. So a linked list works that each element points to the next, points to the next, points to the next, until you get to the end, and then the last element points to, as we can see, a null value. To help us visit the list and visit all the elements in the list, we also have a pointer called head that's at the top of the list, and that allows us to visit each element one at a time. But the head pointer always points to whatever is at the start of the list, and the last element of the list points to null. So that's our basic linked list. Now we've seen it in pseudocode, so how do we do that in Python? Well, in Python, to create a node, and we're going to call it list node, what we do is we say class list node, then we define a method called underscore underscore init underscore underscore that takes in three parameters, a value and a pointer and something called self, and then we say self.value gets value and self.pointer gets pointer. I could tell you what all this means, but unfortunately I'd have to kill you if I did. No, seriously. The way we declare a linked list is we use some terminology from object-oriented programming. Because of that, I don't want to get into it at the moment, but in next year, when you look at object-oriented programming, you'll understand exactly what init does. But for the moment, all we're going to do is just say that to declare a node, we just do this. We create a method called init, and we declare it like this. So once we've declared this type called list node that has two values in it, a value and a pointer, then we can declare instances of it. So if I want to declare four nodes, the first node has the value is 23 and points to the second node has a value 62, points to the third node has a value 37 and points to the fourth node, and the fourth node has a value 31 and points to null. It is important the order in which we declare the nodes. We have to declare them in reverse order. So if we have four nodes in the linked list, we declare them as node 4, then 3, then 2, then 1. Why? Because when we declare node 4, then we have an element that has a value that points to none. Then to declare node 3, what we say is it's got a value 37 and it points to node 4. So we can't declare node 3 and say it points to node 4 until we've declared node 4 first. So when I declare values in the linked list, I do them in reverse order. We can't declare node 2 until we've defined node 3, and we can't declare node 1 until we've defined node 2, because that's what it points to. But in essence, what we get is that linked list with 23 pointer to 62 pointer to 37 pointer to 31 pointer to none, and we'll recall that in Python the null value is represented as the word none, capital N, small o-n-e. In other languages the word is null or a zero, depending on what the language is, but in Python it's none, N-O-N-E. So when we talk about a null value, in Python we mean the word none. And then if I wanted to print out the values, nonetheless, I could print them out in order 1, 2, 3, 4. I could print them out in order 4, 3, 2, 1. I could print them out as 2, 4, 3, 1, whatever order I want to print them out in. But printing them out in orders 1, 2, 3, 4 probably makes sense to see the order of it. All we'll get then is the numbers. We could make it a little more posh by just printing out an open square bracket, the first value, close square bracket, pointer to the next value, pointer to the next value, pointer to the next value, and then pointer to the word null. And that would look like this: 23 pointing to 62, pointing to 37, pointing to 31. We'll note that we're printing out the word null there, even though, as I said, in Python, the word is none. But the user doesn't need to know that. The messages we print out to the user, why do they need to know that in Python it's stored as none? If they're used to or expecting the word null, let's just print out the word null. So that's just a program that we could print out all the values in a linked list prettier than just a row of numbers or a column of numbers. If we want to if we don't know the number of values in a particular linked list and we want to print them out, then we need to use a loop. and loop around until we've reached the null value. So we start at the head node and work our way all the way through, keep printing the value out, and then keep moving one onto the list. So let's look at that code in a little more detail. We define a method and it's called print nodes with a loop. It takes in no parameters, there's nothing in the brackets. And then all of these programs are going to have a global pointer called head, or head node in this case, that points to the head of the linked list. Because I'm using that global parameter or global variable in this particular method, I need to let Python know the variable called head node I'm using in this particular method is the same head node that's being used in all the other methods. So by putting the word global in front of it, I'm saying this is a global variable that can be accessed by all methods. And then for the local program, I'm going to create a pointer called current, and current starts at the top of the list. And then we're going to check if the top of the list is blank. If the top of the list is blank, then there are no values in the list. So you can see the if statement there. The main body is, if it's not none, do something else, print empty list there towards the bottom. So towards the bottom it says else print empty list. So if it's an empty list, you'll find that the pointer points to nothing. If it's not an empty list though, then we're going to have a loop, and we're going to keep on looping until we get to the end of the list. We're going to print out the first value in the list, and then we're going to move the current pointer from the first node to the next node, and we just say current gets the value of current.pointer. So if I'm at node number 1, I have two things in it, a dot value and a dot pointer. The node dot value is the next node in the list. Node dot pointer, I beg your pardon, is the next node in the list. So then all we need to do is move on to the next pointer, the next pointer, the next pointer. So as long as we keep saying current gets current.pointer, that means we'll keep visiting each element of the list. And we keep on looping until we get to the last element of the list. And the last element of the list will have pointer equal to 0. Now when we've reached the last element of the list, we also have to print out that element. So then after the end while, you can see there's a final print statement which prints current.value, which is the final element in the list, which has a value, but its pointer is none. In the pseudocode, I don't think I've necessarily included that last print, but that's the difference between design and development. In the implementation, you often have to add in little tidy up bits after a loop exits or things like that just to make it work fine. So that's the main structure of the program. The main structure is it's an if statement. If there's nothing in the list, print out the phrase empty list. If there is something in the list, loop around until we reach the end of the list. Keep visiting each value and printing out each value. And as I said, the global means we're accessing a global variable. And what we get is simply each value printed out: 23, 62, 37, and 31. Now, if we wanted to make this program a little bit fancier, we could add in another variable called count nodes to count the number of nodes in the list. And each time we're inside the loop, we can increment count nodes by 1, and then we'll add 1 on at the end for the last value, and then we could print out count nodes. And what that would result in is the same output, but just all the values, and then a print of how many nodes there are in the list. And in this case, there's 4 nodes in the list. So that's not a big change, but it's sometimes handy to have a count variable in and just increment it each time you're in the loop. If I want to create an empty linked list, it's very easy. I just take in the head node and I say head node gets none. That means that this linked list doesn't point to anything. So the head points to null. That means I've got an empty linked list. Equally as well, if I want to delete a list, all I need to do is set the head pointer to null again, or none. Once I've set it to none, that's it. I've deleted anything it pointed to before, so that means I'm pointing to a blank list. So that deletes the list. If I want to check if a list is empty, it's kind of the same logic. I just return if head node is equal to none. So we know that the equals equal sign means is it equal to, and is head node, that is the head pointer, equal to blank. If it is equal to blank, then we'll return true, the list is empty. If it does point to a value though, then we return false, and we say that the list is not empty. If we want to find a particular value in a list, then we read in the value we're looking for as n. This program goes over 2 pages. In the first page, it's easy stuff. We just declare a method using the def command. It's called find a node, and it takes in a parameter in, which is the value we're looking for. Could be 23, 61, 67, whatever number we're looking for. And then we're going to get our global head node pointer, and we're going to say current is equal to head node. Then to find our value, we've two real conditions in our while loop. Either we get to the end of the list or we get to the value we're looking for. And inside the loop, all we're going to do is keep looping around and moving one across the list by saying current gets current.pointer. So that moves the current pointer from the first node to the second to the third to the fourth and so on. If we have found that we've reached the end of the list, that means the value n isn't anywhere in the list. So if current.pointer is none, that it means we've reached the end of the list. We print out the value n is not in the list. Otherwise, if current.pointer is not none, that means we've found the value we were looking for, and we can print out found value. If we typed in 67 and then it prints out found value 67, that's fine. But that's the two conditions on the loop are important there. Check when stop looping once we've reached the end of the list, or stop looping once we've found the number we're looking for. Keep visiting every pointer until we get to either null or the value we're looking for, and if we stopped, and if when that loop finished, we're at the end of the list, that means the value isn't there. But if it hasn't stopped at the end of the list, that means the value was found. Inserting a node, and again, this is over 2 pages, takes in two parameters. It takes in the position we want to insert the node into, and it takes in what value we want to put into the linked list. So again, we have our global head node, and we say current gets head node, same as usual. Because we're inserting a new node, we need to create that new node, and we can see a picture of it there. We're taking in a value n, it could be 21, so then we're going to create a new type of list, a new node that has value 21, we'll say, and points to nothing for the moment, or null. And we're going to have a position counter that just counts where we are at the list at the moment. So let's say I call this program by saying insert a node at position 4, the value 26. So what we need to do is go as far as the fourth element on the list. So our position counter will go 1, 2, 3, 4, and then we'll add a new node in, and we'll make the fourth value point to the new node, and the new node's pointer then point to the fifth value on the list. So the code, as we can see, looks like this. Is quite straightforward. If the position I've specified to put the new node in is 0, that means what I'm saying is add a node to the start of the list. So that means what I need to say is the head node now needs to point to the new node, and the new node now needs to point to whatever the head node was, which is current. So that means we've inserted the value at the start of the list. Otherwise, what we do is we keep looping and keep visiting each value on the list until we've reached the position we're looking for. And we visit each element by saying current gets current.pointer as usual, but we need to increment the position counter as well. Then when we end that loop, wherever we stop, then we say the new node we've created, which is called node x, now is pointing to whatever current is pointing to, pointing to the next value, and the current pointer now points to the new node. So exactly as we saw in the pseudocode, when we reach the point we want to insert a value in, get the value before to point to the new node, and get the new node point to the value afterwards. So current is the value we're at, and current.pointer is the new node. So current points to node x points to the next value, current.pointer. Simple as that. How do we delete an element from the linked list? Well, we delete an element by specifying its value, and that value is n. And we have our global head pointer as well. We'll remember in the pseudocode how we do this is with 2 pointers going across, previous and current, and they visit each element. It starts off that previous points to nothing and current points to the head, and then in the next iteration, current points to the next value and previous points to the head. Then they both move on until we find the value we need to delete, and then the previous will point to the one after the current, the deleted one. So how does that look in our code? Just check first if the first element is the one we need to delete, and that would be great. If it's the first element we need to delete, all we need to do is change what head pointer points to. Instead of it pointing to the first element of the list, have it point to the second element of the list. How do we define the second element of the list? It's current.pointer. Otherwise, if it's not the first element of the list, then we just need to keep looping until either we've reached the end of the list or we've found the value we're looking for. And we keep moving on. Previous gets current, that's moving it on, and current gets current.pointer, that's moving that on. Then when we reach the point at the end of the loop where we've found the value we're looking for, then all we simply have to do is say previous.pointer. It doesn't point to current anymore, it points to current.pointer, so previous now points to whatever current is pointing to, and that current node then is deleted from the list. So that's it. Thanks very much. That's Python's version of linked lists. See you on the next episode.